Okay, here is the notes for 2.1, Day 1, Linear and Quadratic Functions, and take some time to read over this. But we're mostly graphing our functions, our linear functions and our quadratic functions in these notes. In a previous class, you probably spent months working on this. In here, we're just going to review it in a day, and then we're going to move on to modeling with these functions. So for some of you, you might remember all this. For others, it's just a review, so that way it'll come back to you and you can use this. All right, so the definition of polynomial function is a function in this form where n is the degree and n is a whole number. So we want to be able to recognize which are polynomial functions when we see them. So which of the following functions are polynomial functions? For those that are, state the degree and leading coefficient. For those that are not polynomials, state why not. So this one right here, well, it does have an exponent here and it is a whole number. So I'm going to say yes, it's a polynomial. It has a degree of 2 and a leading coefficient. Well, that has to be, if we were to put this in order in standard form, we would have the term with the highest exponent first, because you can see that we have n, then we have n minus 1, and then n minus 2. So the exponents are getting smaller as we read it from left to right. So that means that the negative 5 is the leading coefficient. Okay, for this one, no, it is not a polynomial because it's a square root function. If I were to change this into an exponent, the exponent that represents square root is 1/2, and we want a whole number. Okay, for this one, yes. The degree of the polynomial, well, we're looking for the largest exponent, so that would be 4. And then the leading coefficient would be the number in front of that variable with the largest exponent. So for this one, it's 2. Okay, how about this one? Well, this one actually is yes, and let me show you why. Because we could have an x here to the power of 0. X to the power of 0 is just 1, and 1 times 6 is 6. So in this case, our degree is 0, and our leading coefficient is 6. And then this, I know this is kind of blurry, so let me write this a little bit bigger for you, but this is 2/3 the exponent. So this is not a whole number, so no. And then let me show you what this would look like. If I were to change this, this would become 3 and 4 times x squared and then minus 5. Okay, so this is a cubed root function. Okay, for the remainder of this section, so these notes, we will deal only with functions whose degree is less than or equal to 2. So polynomials of a degree 0, like this one right here, is just a constant. Polynomials of degree 1 are called linear. And polynomials of a degree 2 are called quadratics. So for these notes here, we're just going to focus on these type of polynomials. Okay, so all the forms here, slope-intercept form, point-slope form, and standard form. So slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. Then we have point-slope form. This looks like y minus y1 equals m times x minus x1. And in this case, our m is still slope, so you can write it down here again if you need it here. And then our point is represented by these parts of the equation. So this is a point. And then our standard form looks like this, ax plus bx equals c, and c in this case would be a constant, so just a number. Okay, and then a reminder, the slope formula, if you've forgotten, is y2 minus y1 over x2 2 minus x1. So the important thing is that you have your y's on top and your x's on the bottom. Okay, to write the equation of a line, you need a point and a slope. So for each of these, we're going to find a point and a slope, so that way we can write the equation of our line. So write the equation of a line in slope-intercept form. Okay, well, over here, such that f of 3 equals -1 and f of -2 equals 9. So really, these are just a couple of points. This represents the point 3, -1, and this represents the point -2, 9. Okay, but it's asking for slope-intercept. Well, I don't have an intercept. So what I'm going to do is I'm actually going to put it in point slope form and then manipulate that equation to get it to where I want to be. So I need a point and a slope. Okay, my point could be either one of these. It doesn't matter. I'm just going to choose 3, -1. And now I'm going to have to find the slope. So I'm going to take my change in y. So 9 minus a -1 is going to be +1. And then -2 minus 3. So now I have 10 over -5. So my slope simplifies to -2. Okay, now I can put it in point slope form. Y minus, so we're actually going to put the opposite sign in here. So minus a -1 would become +1 equals my slope, which is -2, times x minus 3. Okay, so to put in slope-intercept form, I just need to manipulate this equation and get y by itself. So I'm going to start by distributing over here. So on the left, nothing's changed yet. And I have -2x plus 6. And now I'm going to subtract 1, and I can only subtract it from there. So I get y equals -2x plus 5. So here is our answer here. I know for some of you, this is just, you've got it. You've seen this many, many times before, but I know also there's going to be people who have forgotten, and we want to make sure that we're strong at this. Okay, write the equation of a line that is perpendicular to this line and passes through the point 3, -5. So once again, I'm going to need a point, and I am going to need a slope. Okay, so we know the equation is going to pass through this point, so let's use this point. And now, what is the slope of our line? Well, it's perpendicular to this one. So if the slope of this one is 2/3, then the slope of the perpendicular line is the negative reciprocal of this. So you have to both turn it upside down, so 3/2, and you also have to make it the opposite sign. So you got to remember that perpendicular is negative reciprocal. All right, now I'm going to do y minus -5. Makes it +5 equals -3/2 x minus 3. In this case, it's not telling us to put it in slope-intercept form, so I'm going to just leave it like that. That's totally fine. That is an equation. We don't always have to take it further. Okay, write the equation of a line that has the y-intercept of 0, 5 and a slope of -2. So we already have a point and we have the slope, and the easiest one that's going to, we could put it in this form. But since we're telling it's a y-intercept, we might as well just put this in slope-intercept form, where the slope goes right here. And then our intercept, well, if you can imagine this, the x is 0, it's at 5, so our intercept is right here. So it's going to look something like, whoops, totally missed that line, or that point. It's going to look like that, and we get +5. Okay, so let's look at graphing these. So how do we graph these? Hopefully this is familiar to you, and this is just a quick review. But here I'm going to go and plot the intercept first. So let's just make a little note here that this is the y-intercept. Let me fix that. This is the y-intercept, and this is the slope. So 1, 2, 3, 4. And now I can just plot this slope here. I go up 1 and over 3, up 1 and over 3. Long lines that stretch out over our coordinate plane and have arrows at the end. All right, coming over here, we have a point and a slope. That's all we need to graph this. So let's pull out our point. Remember, they're going to be opposite signs. So over here with the x, I'm going to pull out a 3. And over here with the y, I'm going to pull out a -4. So I can plot the point 3, -4. So is right there. And then my slope, -1, so down 1 over 2, down 1 over 2, and draw on that line. Okay, let's graph one more. So when it's in standard form, sometimes you can graph straight from here, and other times it's nice to put it in y equals mx plus b. If these numbers here go evenly into this number, it's nice to just find the x and y intercepts. And the way you do that is, let's say we're plugging in 0 for x. So if I plug in 0 for x, then that's going to be 3 times 0. That's actually just going to get rid of that. So now -4 would go into -12 3 times. Then I can plug in 0 for y and find out what the x is. So if I plug in a 0 for y, -4 times 0 is just 0, gets rid of that. And now I'm going to divide this 3 into -12, and I get -4. So this is an easy method, but it's just not that convenient in a lot of cases. So 0, 3, and -4, 0. And there's our line. Okay, so now we're going to get into quadratics. So let's look at the different forms here. And we have vertex form. And this is when, and I'm just going to put an f of x equals plus or minus a x minus h squared plus k. And the plus or minus is the open up or down. We can recall that that has to do with a vertical flip, that out there. The A is the stretch or shrink. And then our vertex is going to be HK is our vertex, and that's why it's called vertex form. And this should make sense because we just looked at transformations, and if this is going to move it left or right and this is going to move it up or down, that's going to tell us where that vertex is. And then this is going to tell us how much to stretch or shrink it, and this is going to tell us if we're going to flip it or not. Okay, standard form. Standard form looks like this. AX squared plus BX plus C. So this is what we're seeing a lot of our quadratics presented to us in this form. And then intercept form is just the factored form. So just a different name for the factored form. And not all quadratics are factorable, but when they are, we would see it something like this. A x minus r sub 1 and x minus r sub 2, where r is the roots, are the roots, or x-intercepts. Okay, the axis of symmetry. So the axis of symmetry, I'm going to draw a little drawing here. So if we have a parabola like this, our axis of symmetry, this is so not straight, our axis of symmetry is going right there down the middle. Do your best to draw something that does not look all wonky like that. And the formula for finding the axis of symmetry is -b all over 2a, which might sound familiar from the quadratic formula. And in the past, you probably found out where this came from, but it did come from the quadratic formula. And then if you want to find the vertex, well, the vertex, of course, is this point right here. You would take the x that you found when you found the axis of symmetry, and then you would have to plug in x into the equation. We'll try that in a little bit. So plug in x to find the y. So we could find the x with that formula, and then we would have to use it to find the y. Okay, so graphing. So we're going to find the vertex of the quadratic function, then graph the quadratic function. So our vertex, and remember that this is going to be opposite than what's in here because our vertex formula or vertex form shows a minus, a negative here. That means when we pull it out, it's actually going to be the opposite sign. So this is going to give me a -5 and -2. Okay, so I found my vertex, -5, -2. But that's really not enough to graph my quadratic. So I want to know how steep to make my walls here. Well, I can look here to find the stretch and shrink. And if you recall, a regular, or the parent function rather, I shouldn't call it regular. So the parent function would be x squared. And when that's the case, we have a dot at 0, 0, and then we have a point at 1, 1. And then when we go to 2 and we square 2, we're going to go up to 4. And then we repeat on the other side. So in this case, instead of doing 1, 1, we're going to do 1 and then multiply the y by 3. So 1, 1 is going to become 1, 3. And negative 1 would become negative 1, 3. And then 2 would become 2, instead of 2, 4, would be 2, 12. But I'm going to be okay with just 3 points on this one. Just like that. Okay, so we graphed it. First we had to have a vertex, and then we kind of needed to know what that shrink or stretch looked like and whether it opened up or down. And since this is positive, it is going to open up. Okay, so what if we want to graph it from standard form? So when you graph from standard form, you have a couple of options here, option 1 and option 2. So change to vertex form by completing the square, which I know you guys just love. How do you graph from standard form? You don't. You have to change it into vertex form. So let's change it into vertex form by completing the square. So first you're going to factor out the a from the first two terms. So I'm just going to copy this down, but I'm going to put a parenthesis around these first two terms, and I'm going to find the greatest common factor would be 2. So I'm going to factor it out, and now I have x squared plus 6x inside the parentheses plus 13 over here. Okay, find a number that will complete the square. And I ran out of room, but complete the square inside the parentheses. So I need to find a number that's going to complete the square inside the parentheses. And remember, how to do that is you take b, you divide it by 2, and then you square it. Okay, so that number is going to be this. So in this case, I would take 12, divide it by 2, and square that number. Once you find it, you're going to subtract and add it inside the parentheses. So once again, I'm just going to copy this over, and I'm going to leave some space inside my parentheses, and I'm going to complete the square. So 6 divided by 2 is 3, and 3 squared is 9. And I'm going to subtract it and add it, or add it and subtract it, inside the parentheses. There we go. So that's step number 2. Maybe we even want to number these here. So step 1, step 2, so that you can find them again. All right, multiply the a value by the negative number in the parentheses, and send it out of the parentheses. So in order for any of these to come out and be outside the parentheses, you have to multiply it by 2 first, because you're basically you would have to distribute this to all the 2's. I'm sorry, you would have to distribute the 2 to all the terms if we were to try to get rid of these parentheses. So to get out of the parentheses, this guy's like the gatekeeper. You have to see him first and be multiplied by him. So step number 3, we're going to leave this stuff inside the parentheses. And this guy is going to come out. So 2 times negative 9 is negative 18 plus 13. All right, last step here. Good thing, 'cause I'm running out of room. We're going to factor the parentheses and combine like terms. And remember, we made a perfect square trinomial. That was the whole point here. So it's going to be factorable. And not only that, it's going to be a perfect square. So you're going to just copy this down. And now it's going to be x plus or minus something. Well, these are all positive, so it has to be plus. And then your number over here is just your b divided by 2. You took your b divided by 2 and square it. So before you squared it, it was 3. And combine like terms outside of here. I can combine like terms here, and I get a negative 5. Okay, we now have all the pieces we need to graph this. We have the vertex that we're going to pull out. It's going to be negative 3 and negative 5. So let's find that over here. -3, -5, and then I need to figure out how fast this is going up here. So if this is usually 1 and 1, this is now going to be 1 and 2. If this is usually 2 and 4, this would now be 2 and 8, because I'm multiplying the y, how far I'm going to go up, by the number 2. So 1, 2 up, and I'm fine with 2 points for this. It's incredibly hard for me to draw on this tablet. Okay, there we did it. We graphed it by hand. So option number 2. Option number 2, we're still going to change it to vertex form, but we're just going to use a different method by using the axis of symmetry formula. So use the axis of symmetry formula to find the x of the vertex. Okay, so like I mentioned before, I love completing the square, but if you're more of a formulas person, then maybe this will work out better for you. Okay, so our axis of symmetry formula is this. So now I'm just going to plug in my b. I get -8. And I'm going to divide by 2 times -2, my a, which is right there. And -8 divided by -4 equals a +2. So I found out that the x, and here I'm going to put my vertex here eventually, so I'll go ahead and put the 2 in. The x is 2. So plug in the x of the vertex into the original equation to find the y of the vertex. Let's make this a little cleaner here. Okay, so we have 2. So now I'm going to take this and I'm just going to plug in 2 everywhere there's an x. So I'm going to evaluate at 2. So -2, make a home where there's the x, plus 8, make a home where there's the x, plus 4. Now I can go back in and fill in with 2. 2 times 2, or 2 squared, is 4. 4 times 2 is 8, and it is negative. Plus 2 times 8 is 16, plus 4. Simplify all this, and I get 12. Okay, so that's great. We have a vertex, but just a vertex alone isn't really enough for us to graph this. But let's see where that is. 2, and then I'm going up to 10, and I am actually a little bit off the graph unless we want to count by 2s on here. Either way, I'm okay with us going a little bit off the graph. So I'm just going to call this 212. All right, find the GCF in the first 2 terms of the original equation. This will become the A. So what am I going to pull out here? I'm going to pull out a -2. So our GCF is -2. And that's going to tell us whether it opens up or down. So I know it's going to open down, and I know it's going to stretch by 2. You can write the equation in vertex form, if need be, and then you can graph it. So vertex form of this guy then would be f of x equals, the GCF is -2. The vertex is right here, so x minus 2 plus 12. Okay, one little catch here, I am missing something. This does need to be squared, otherwise it's not a quadratic. Okay, so now let's graph the answer. So we have the vertex. We know it's going to open down, and we also know it's going to stretch. So if we go over 1 and down 1, typically we're going to go over 1 and down 2. Over 1 and down 2. And opening down looks like this. Okay, also graph this in Desmos to show you. Here is our parabola in vertex form, and then here it is as it was originally given to us, and they do fall right on top of each other, so it's the same equation, and that's just a good way to check when you're practicing these. Okay, so what about when it's intercept form? Well, everything's already kind of there, so you just need to pull everything out. So find the roots in the equation. So remember, the roots are just right here. and it's going to be the opposite of what's there. So we're looking for the the x-intercepts. So we're going to pull this out, and this is going to be positive 1. So 1, 0. 1, 0 is right here. We might as well just put it on there. And then negative 3, 0. So negative 3, 0. So we know that's where it crosses the x-axis, but that's not really enough information for us to draw this correctly. We also are going to find out what the vertex is. And that's pretty easy to do because we're just going to find the point that is halfway between the roots. This is the x of the vertex. So what point is halfway between the roots? Well, we're just going to take 1 plus a negative 3 and divide by 2. This is negative 2 divided by 2 equals negative 1. Now this one came to a whole number, but when we're dividing by 2, you can see that sometimes we're going to end up with some number and a half, and that's totally fine too. All right, so plug in the x of the vertex into the original equation to find the y of the vertex. Okay, so we are going to go ahead and plug this in everywhere there's an x, so negative 2, make a home for the x. There we go, plug in negative 1. I should have actually made this negative 1 here. So negative 1 here, negative 1 here. And we have negative 2 times a positive 1. Nope, a negative 2. I'm multiplying instead of subtracting there. So negative 2, and then 2. So negative times a positive is going to give me a negative, and a 2 times 2 times 2 gives me 8. So I did find the vertex. Let's go ahead and write it right here. My vertex is negative 1, 8. Now we can put this at negative 1, 8. Whoops, negative 1. Okay, I think it's pretty obvious by our graph here that it's going to open down, but it's always nice to check and look at the sign. So if it is a positive, it's going to open up. If it's a negative, it's going to open down, and this does in fact open down, which makes sense with what we see up there. So we can connect the dots. There we go. And we have graphed our quadratic by hand. All right, that's all the notes. I would like you to try to do all of these things.